Alright, typically you see this word rational and you could think fraction. Right now we're going to go through an example. I'm going to first use, a very basic fraction and relate this to rational expressions with variables and go from there. Alright, so when you learn fractions, besides learning the basic what a fraction is, typically we learn how to multiply and divide them before we learn how to add or subtract. Let's go ahead and do subtract because it's easier. So for instance, multiplying these two, first off, if you know cross canceling, which I will almost always use because it's quicker and easier for me, but these twos would cancel and we know we'd get 1/3, right? 2 goes into 2 once, 2 goes into 2 once, and we get 1/3. However, if you do it the kind of old school way, multiplication, we can multiply the numerators, so ultimately we have 1 times 2, and in the denominator we have 2 times 3. Now the reason cross canceling works is because I would rewrite this as 2 over 2 because multiplication is commutative, right? We could do it 1 times 2 or 2 times 1, either way, multiplied by the 1/3. You could see from the start, right, these are identical. I just rearranged the order, and the reason we did that is because 2 over 2, this guy here equals 1. So we have 1 times 1/3, which is, again, 1/3. Alright, now let's look at this subtraction problem, though. Addition would be the same. We just add the numerators rather than subtracting. Now, we need an LCD, right? So, LCD of 2 and 3 is 6. Therefore, 1/2, I need to multiply by 3 over 3. And the 2/3, wanted that black, not that big of a deal. We need to multiply by 2 over 2. Now, quick side note, really quick, why we could do this, 3 over 3 is just 1, right? 2 over 2 is just 1. We're multiplying by a form of 1, so we're just changing the way it looks, not necessarily changing the problem whatsoever. So this is now 3/6 minus 4/6. And if I have 3 out of the 6 and I take away 4, well, I'm in the whole 1 actually, right? 3 minus 4 is negative 1/6. This was a lot more work, especially the first example with multiplying. If we cross cancel, is 1 step and we're done. Here we're to get an LCD and go from there. Alright, let's take that and relate it to an example closer to what we will be doing. So let's take, how about 2x over x plus 2 multiplied by x plus 2 over x minus 2. Okay. Multiplication, again, if you know cross canceling, x plus 2, we could cancel those and we're done. Right, we just simply have 2x over x minus 2. That is all that is left because x plus 2's would cancel to 1's. Even if you are not comfortable with cross canceling, we have 2x multiplied by x plus 2 over x plus 2 times x minus 2. And rearranging them just as we did before, right, just like we did here, we would change this to x plus 2 over x plus 2 multiplied by 2x over x minus 2, and you could see they result to the same multiplication. Again, x plus 2 over x plus 2 is just simply 1. And we're only left with 2x over x minus 2. That's it. That is the answer. Really quick, a common mistake is many students see these x's and they want to try to cancel. Let me go ahead and write this one more time. Okay, we tried, many students I see trying to cancel these x's, and that doesn't work. Canceling only works with multiplication, and right here I have this x minus 2. That's subtraction. Right? Another way to verify that this in fact doesn't work, if they canceled, what's left? I guess 2 in the numerator and negative 2 in the denominator, right, which is negative 1. Before I get too far, I'm going to cross this out. Ooh. No. Sorry. Clicking places. I'm going to cross this out because this does not, in fact, work. Right, but to verify that, let's just say, let's let, x be 3. Really, it could be anything. But if we had 2x over x minus 2, that would mean I'd have 2 times 3 over 3 minus 2, which is 6 over 1, right? Which is not the same as this. Those two are not equal. So I could tell by letting x be any random number that, right, if I were to cancel these x's, they do not come out the same. It doesn't work. Okay, moving on. Let's take the same problem. Kind of getting cluttered a little bit. 2x over x plus 2, but let's subtract. Okay, again, just as we did before. Right over here, when we do addition, subtraction, we have to get an LCD. Well, LCD in this case is just x plus 2, x minus 2. If you're ever unsure, you could always multiply, just like we did here, 2 and 3, right? LCD was 2 times 3, which was 6. LCD here, x plus 2, x minus 2. Mimicking what we did before, we have then 2x over x plus 2. We need to multiply by the factor that's missing, x minus 2 over x minus 2. Just as we did over here with the 1/2. Right, we had to multiply by that 3 over 3. Same idea. If you're ever unsure what to do, think of a basic fraction and see if that'll help. The next factor was missing, the x plus 2. Alright, now we have our LCD. I'll go in and rewrite this one more time. The 2x multiplied by x minus 2 over x plus 2, x minus 2, minus x plus 2 times x plus 2 over x minus 2, x plus 2, which is the same as our other one. I chose to do an example with the subtraction because another common mistake is when we do put this all, let's go in FOIL, when we do put this all in the numerator, oftentimes the subtraction is forgetting that we're subtracting everything up here. Okay, so 2x times x, 2x squared. 2x times negative 2, negative 4x. Alright, now we have this minus, right? Minus. It's common to group our first fraction and then our second fraction, especially with a negative, because then it helps us remember to subtract everything that's in here. Alright, foiling this, we have x squared plus 2x plus another 2x. Right, so I'm going to skip a step here and just say 4x because we have two 2x's. And then plus 4 all over this LCD. Okay, x plus 2x minus 2. Now, this takeaway, right, we have 2x squared minus an x squared. Right, when we bring that in, minus x squared. So 2x squared minus 1x squared is 1x squared. Then we have negative 4x minus a 4x. Again, distribute that negative through. So negative 4x minus another 4x is negative 8x. And then one last time distributing this negative through, it was a plus 4, now it's a minus 4. All right, all over that LCD, x plus 2, x minus 2. This numerator isn't going to factor. This is about as reduced as we can get. Again, even if you FOIL this denominator through, oh geez, I'm out of room. We'll just squeeze this up right here. Even if we FOIL that through, we have x squared minus 8x minus 4 over, I'm going to skip a step, this is difference of squares, right? So we should have x squared minus 4. Again, just like above, we cannot cancel anything here. We can't cancel these x squareds. We can't cancel these negative 4s. This is subtraction. Addition and subtraction doesn't work like that. We can only start canceling when it's multiplication. Don't get cancel happy. Right? This is the answer. Either here with the denominator factored or here. Can't do anything more. Alright, hope that helps.